Problem number 7 is telling you to use a graphing utility to graph this function. So I entered this function into the Desmos graphing calculator, and this is the image that I got. Okay, so notice that it crosses at 100, and then as you get it keeps getting closer and closer to 0 as it goes on from there. So you might want to reference, draw yourself a little reference graph of what you saw in Desmos. So I'm going to put 100 right here, and it went something like this. Okay, it's not exactly great, but it's close. Okay, so you're supposed to match the graph with one of the choices that you have in Pearson. So match the graph that most closely matches it. Be careful with the one that you pick, because there are two that look the same, and the difference is that this one does bow out a little. The other one hugs the line completely. So be careful with your choices here. Okay. Part B is asking us to, let me see, in a room of n equals 40, this was part A. Part B, a room of n equals 40 people, what is the probability that no two share the same birthday? So we're using 40 in the place of n, and we're doing the actual calculation. And we're going to put 40 in the place of that n. So even on your graphing utility, let me see if I can bring that back up. If I put 40 in the place of n where I typed in the n to show my graph, if I put 40 in the place of n here instead of n, it'll give me a value here. So I put 40 in the place of n, and that's the value that I got. So I'm going to write this out. So I got 20.924133894, and it's telling me to round to the nearest integer as needed. So if I round this nearest whole number, this would be, if I'm rounding to the nearest whole number, this one is 5 or more, so this would be about 21%. Okay. And then part C is asking how many people must be in a room before the probability that no two people share the same birthday falls below 12%. So if we're talking about something that's going to fall below 12%, we're going to set this equal to 12, and then we're going to do the actual calculation from here. And we're solving for n. Okay. So if we start by working this problem out, I have a fraction. I'm going to clear the fraction, so I'm going to multiply both sides by my denominator, which means I'm going to multiply 12 times 1 plus 0.115 e to the 0.0912n, and that's going to leave me 113.3198 on this side. And then if I divide both sides by 12, that's going to be 1 plus 0.115 e to the 0.0912n is equal to this number. So let me calculate that number. I'm going to the scientific calculator, and I'm going to enter this into Desmos. Or if you have just a regular calculator, you can probably do the math there too as well. So I have 113.3198 divided by 12. And that gives me 9.44331667. And then if I subtract 1 from both sides, that gives me 8.4433166667, 0.115 e to the 0.0912n. And if I divide both sides by the 0.115, that leaves me e to the 0.0912n is equal to this number. So I have 8.443316667 divided by 0.115. Now be careful with trying to round your numbers here. You don't want to round these anytime that you're working in the problem. That's why I'm saying write out the whole thing, because it can mess up what you get as a decimal. And I believe on Pearson it also tells you do not round until the very end. Okay, so now I'm down to this, and if I looked at this and I rewrote this as a log, remember this is your base, that's your exponent, that's your answer, so I would have log or ln of 73.4201443 is equal to, and my base was an e, my exponent was 0.0912n. If I'm solving for n, then I just simply divide both sides by this 0.0912, and I get my value there. So I'm taking the ln of 73 point all that other stuff and dividing that by 0.0912. Oops, forgot the 0. So I'm entering this into my calculator. So I have ln of this number divided by 0.0912, and I get this answer. So I'm going to write that answer out. And it tells me to how many people must be in the room before the probability that no two people share the birthdays that fall below 12%. Now, on this one, you got to be careful because we're talking about people here, and you don't want parts of people. So when you round this one, you want whole people. So you round it up to the next whole person. Okay? And that should be the last part of this problem. Oh no, there's one more part. Part D. Let's see, that's Part D is asking what happens to the probability as it increases. So whenever you look at your graph here, you need to understand that this is the number of people and this is the probability of those numbers. Okay, so make sure that you're labeling these correctly. And we saw that this one did something like this, and this was at 100. Okay, so as n increases, because we saw that it was going like this on that graph, okay, as n increases, p of n approaches 0. So that is true. This one's going to get closer and closer and closer and closer to this line, but it's never going to cross the line. That means that the number of people in the room increases, that as the number of people in the room increase, the more likely that two will not share the same birthday. Now that's not true. The more people that you get, the more likely people are going to share the same birthday. So let's see, I'm going to go with the answer choice that makes more sense here. And there's two of them that say as n increases, p of n approaches 100. And that's not true. Okay, p of n is getting closer and closer to 0. So you're looking at the two that state that. One of them says that the two people will not share the same birthday. Other one says that two people will. The more people you get in the room, the more chances that that's going to happen. And that was the end of